All right, today we're going to be talking about energy, and we're going to be taking some notes on that. So you need to make sure you have this paper. As we go through and talk about the different forms of energy, you're going to write them down on this notes page. And then at the end of the video, we're going to go through some examples of different forms of energy, and you need to flip the paper over, and we'll tell you when to do that. Okay? So here we go, talking about energy. All right, energy is what makes matter move or change. All right, so the very top of your paper. Energy makes matter move or change. So movement is probably pretty obvious that it takes energy to make something move, but also it takes energy to make matter change, like in a chemical reaction. All right, those involve energy. And you've seen that when you see that the chemical reactions get warm, they release energy, so it took energy to make those things happen. And also when you have a chemical reaction and it gets cold, well, it absorbed energy, and so absorbing that energy took the heat away, and that made it colder. Okay, so energy makes matter move or change. All right, next we're going to talk about the different forms of energy or types of energy. All right, so one type of energy is going to be on the left side of your paper, and the other type of energy is going to be on your right side of your paper at the top. Okay, so potential energy is energy that an object has because of its position or its shape. Okay, now what does that mean, position or shape? Potential energy has the ability to do something. Okay, potential means possible. And remember that energy makes matter move or change. So potential energy means it has the possibility of moving or changing something because of its position, meaning of where it is, or its shape. Okay, we're going to see some examples of that in just a little bit. So that's potential energy. All right. Also at the top of your paper, there's kinetic energy. Kinetic energy is energy that something has because it's in motion. Okay, like this race car right here. All right, this race car is moving. Kinetic means motion or moving. So this race car has kinetic energy because it's moving. So anything that is moving has kinetic energy. All right, and just real quick, let me go back to the potential energy one. We have a picture right here of a roller coaster. Okay, the top of a roller coaster, right before the coaster starts going down, it's stopped at the top of the hill. That coaster has potential energy because of its position or where it is at the top of that hill. Okay, and we'll learn a little bit more about that later in the video. Okay, but I wanted to make sure I talked about that picture. All right, so potential energy at the top of your paper and kinetic energy, energy of motion at the top of your paper. All right, now we're going to talk about some specific forms of potential and kinetic energy. All right, so chemical energy is the energy stored in the links between atoms. Chemical energy is a potential energy because it's not yet been released. All right, this is like the energy that substances have before they undergo a chemical change or chemical reaction. All right, let's say you're going to mix two substances and they have a chemical reaction and it releases heat. All right, before it actually releases the heat, it has chemical potential energy. All right, some other examples are like batteries have chemical potential energy because of the chemicals in the batteries. They have potential to release that as electrical energy. All right, food has potential chemical energy because once you eat it, it gives your body the energy it needs to move and to live. Okay, firewood has potential chemical energy because before you light it on fire, it's just sitting there, but once you light it, it releases that energy, so it's stored potential energy. Candles before they're burning. Okay, fossil fuels, oh my goodness, there's a lot of energy, chemical potential energy in fossil fuels. Okay, so chemical energy is energy stored in the links between atoms. Okay, nuclear energy is the potential to release energy when atoms splits apart or when two atoms join. Okay, there's two kinds of nuclear potential energy. Alright, you can get energy out of atoms two ways: by fission, which means a large atom splits apart. Okay, and this happens in nuclear power plants and some types of nuclear weapons, okay, and nuclear bombs. That's called fission, when the atoms split, okay. And then there's fusion, which is when atoms join together or get fused or stuck together. That also releases a bunch of energy. That's what happens in the sun, okay. So that is nuclear potential energy, okay. The next one, gravitational energy, is the energy of position or place, okay. You all know that gravity can pull things towards the center of the Earth, because Earth is such a huge object. It has so much mass, it can attract things by gravity, okay. So gravitational energy, something has gravitational energy because of its position or place, like being up above something on the surface of the Earth, okay. Like a rock resting at the top of a hill has gravitational potential energy because all it takes is something to just make it move and it'll roll down the hill. And then like the water above or behind this dam has gravitational potential energy because once you release it, it will fall down the dam and roll down the river, okay. Rivers run because of gravity. So hydropower is something like that takes advantage of gravitational potential energy. Alright, so when the dam releases this water, it can go through a generator and turn a generator to make electricity. That's hydropower. It's all because of gravitational potential energy. Alright, the next one is elastic energy. Now this one's a little complicated. It's energy stored in objects by the application of a force. Okay, like compressed springs and stretched rubber bands are examples of elastic energy. Alright, so what do we mean by a compressed spring? That is a spring that is pushed together. See how this person is pushing the spring together? When it is pushed together, it has elastic energy because when that person lets go of it, it's going to spring apart, right? Just the spring sitting there without being pushed together, it would not have elastic energy. Okay, same thing with the rubber band. Okay, when the rubber band is stretched, it has elastic energy because when you let go of it, it's going to spring back together. It's going to squeeze together. Okay, so when a rubber band is just sitting on the table, it has no elastic energy, but when you pull on it, it's ready to be released, then it has elastic energy. So elastic energy is another form of potential energy. Alright, now let's look at forms of kinetic energy. So that means the other side of your paper. Alright, sound is energy of vibrations that are carried by solids, liquids, or gases. Alright, so you hear sounds because something is vibrating the air molecules, and those air molecules are carrying those vibrations from whatever is vibrating to your ear, like this guitar right here. When the guitar player strums the string, it's going to vibrate. That vibration makes the air molecules vibrate, and then those air molecules vibrate other air molecules until they get to your ear, and you hear the vibration as sound. Sound has to travel in something. Has to have a medium to go through. It can go through solids. It can go through liquids, because you know when you've been swimming underwater you can hear sounds. Sounds a little different than in the air, but you still hear sounds. Or you can hear sound through solids, like put your head down on the table and tap on the table. You can hear that tap through the wood of the table. Okay, that's why you cannot hear sounds in space, because there's no air. Since there's no air, the sounds can't travel through anything. So despite what you see in the movies, you cannot hear any sounds in space. Alright, next one, electrical energy. Okay, that's energy carried by moving charges. Now, this gets a little complicated. This electrical energy happens when a circuit is turned on. Okay? So this radio right here has to be turned on for electrical energy to move from the outlet through the wire into the radio to turn radio signals into sound. Alright? If the circuit is switched off, there is no electrical energy because the electricity is not moving. Alright? So a battery that is just sitting there in a circuit and it's not switched on, or the circuit's not closed, there is no electrical energy. A battery has chemical potential energy, but it only has electrical energy when the circuit is switched on and the electricity actually flows. Okay, does that make sense? You got to think of electricity as electrons that are flowing through a wire. And if they're not flowing, you don't have any electrical energy. All right. Next one is radiant energy. That's electromagnetic energy that travels in transverse waves. Radiant energy includes visible light, X-rays, gamma rays, radio waves, and one type of heat is also radiant energy. So we get light and heat from the sun through radiant energy. Okay, you warm up your food in the microwave with radio waves. That's radiant energy. X-rays, you can see through the flesh of your body and see your bones in an X-ray because the energy of those X-rays actually moves through your body. Okay, light, light is energy. You can get energy from light from the sun, if you use solar panels or just stand out in the sun, and the sun's light energy will warm you up. Okay, so those are all forms of radiant energy. All right. Next we have thermal energy, the energy of the movement of atoms. Okay, so thermal energy is kinetic because it's making atoms or molecules move. All right, this cup of coffee right here is warm because its atoms are all moving around because they've been warmed up. Okay, if something is not warmed up, then its atoms do not move as much and it is not going to have heat or thermal energy. Okay. Think about it, when you warm up your hands with friction, if you rub your hands together, they start getting warmer because you are moving them together, and that movement is causing the atoms in your skin to move around and they get warmer. But if you stop moving your hands, they cool off. Okay, so and I know that thermal energy or heat doesn't seem like it's moving, but you got to think of the atoms and the molecules moving around. Okay. Next, mechanical energy. All right, mechanical energy is an energy that an object has due to its motion or changing position. Mechanical energy doesn't have to be in a machine. I know mechanical sounds like a machine, but it doesn't have to be. It's just anything that is moving or in motion or changing position. Even you have mechanical energy when you are moving. Okay. Now flip your paper over and we're going to look at these pictures, and you're going to have to identify the type of energy that's present. Okay. First one, this picture of these people beating a drum. What kind of energy are they producing when they beat the drums? Think about that. The drum heads are vibrating. Those vibrations are being carried through the air from the drum to your ear. What kind of energy is that? Write it down. Alright, this one I'll help you out with. It's sound energy. Okay, they're beating a drum, you hear it, it is sound energy. Alright, next one, number 2. Okay, this water that is falling off of this waterfall, what kind of energy is that? Don't say hydropower because it's not turning a generator. What kind of energy did this water have because it was at the top of the waterfall before it fell? Okay. Alright, number 3, this rock. It's just barely holding on up here at the top of this little mesa. What kind of energy does that have because of where it is, way up above the ground? Okay, think about that. Right, number 4, the candle. Okay, this candle is burning. So that's one form of energy right there. But also this wax, before it burns, has a different type of energy. So there's a couple of different answers that would be okay for this one. Okay. Number 5, what is running through these wires that goes into your house and through your wires in your house and through your outlets and out into your radio or your cell phone? What kind of energy is that? Okay. This one, what kind of energy does this bow have when it is pulled back? All right. All right, this is number 7. Don't let this fool you, because it is a slingshot, but it is not pulled back right now. Okay, it has been released, so it is flying forward. What kind of what kind of energy does this rock have when it is flying forward? It's moving. So is the elastic part of the slingshot. Okay, so it is not being pulled back. It's not being held back. It has already been released and it's flying forward. What kind of energy is that? All right. Number 8, a piece of pizza. Before you eat it, what kind of energy does it have? Okay, think about that. What are you going to use this pizza for? You're going to eat it. What kind of energy does that have that it gives your body? All right, the speed skater. This person is in motion. They're skating around a speed skating track on ice. What kind of energy do they have because they are moving? Okay, and a corn plant. What kind of energy does it have that is stored within the plant? Because the plant, you can see it's doing photosynthesis right here. The sun is shining on it and it is taking in carbon dioxide, releasing oxygen. So it's making its own food. What kind of energy would that food have? All right, that's it.